Okay, let's unpack this. We're opening this deep dive with a moment I think everyone listening can relate to. It's this feeling that's just so visceral, right?
So universal and so unsettling.
Exactly. You're in a place where, logically, you are safe. Maybe you're the last person to leave a big, quiet warehouse, or you're just alone in a dark room at night.
The silence is just thick.
And then it hits you, that sudden, cold prickle of just absolute certainty that you are not alone, that someone or something is watching you.
It's that feeling of being watched when all your senses are telling you the room is empty.
Right.
And we usually dismiss that, don't we? We call it an overactive imagination, maybe something you saw in a horror movie.
We call it paranoia.
Right.
Paranoia.
But based on the fascinating sources you share with us,
Yeah.
the whole mission today is to argue scientifically that this is not paranoia at all. This ghostly feeling is actually one of the most primal, well-documented survival responses our brain has. Exactly. We are diving into the neurobiology of fear. And the core finding here is, well, it's critical. That feeling of being watched activates the exact same ancient brain wiring that processes real, life-threatening danger.
So your brain is reacting as if a lion just walked into the room.
That's it. That spine-tingling feeling is your ancient defense system just running a threat assessment.
So we're talking about a biological validation for that feeling of dread. It's not just in your head, it's a physical response.
Right.
Which brings us to the term the research uses, the hypervigilance circuit.
The term is precise. Hypervigilance circuit. It sounds complex, but its function is actually very simple. Maximum sensitivity to ambiguous threats.
Okay, maximum sensitivity. What does that mean?
It means the circuit operates with an extremely low threshold for activation. It prefers to err on the side of caution. Extreme caution, really.
Let's define what that means for the listener structurally, because this is where it really breaks away from our conscious, logical thinking. What is this circuit actually doing to our perception?
It's forcing the brain to operate on a pure assumption. The definition is almost terrifyingly simple. The brain assumes a threat exists without any physical evidence. No sound, no sight, nothing.
So it just bypasses the analytical parts of the brain completely.
Completely. If the data is incomplete, you're in a dark room, you hear a sound you can't place, the default position is immediate alarm. The assumption of danger is literally built in.
Its whole purpose is just protection.
Its sole, singular purpose is protection. And that's maximized through these very rapid, non-rational alerts. It's a dedicated mechanism designed to keep you alive when milliseconds might matter.
This is a really crucial distinction then. We often call these feelings an illusion, that the feeling itself is fake. But what the sources are saying is that the response is genuine. It's functional even if the threat isn't really there.
Precisely. We have to stop thinking of it as a mental trick. It's classified as a genuine survival response.
Yeah.
When you feel that rush of dread, that's not your imagination. That's the hypervigilance circuit dumping neurochemicals into your system.
The brain doesn't stop to ask if that shadow is a person or a coat rack.
No time. If the sensory input even suggests surveillance, the system triggers. Full stop.
But doesn't that seem, I don't know, wildly inefficient for modern life? We're spending energy, our heart rate goes up, we get a cortisol hit, all for a threat that probably isn't there.
And that's where we have to shift our perspective away from modern efficiency and back to ancient necessity.
Yeah.
It is exquisitely efficient at one thing: survival.
No, okay.
The cost of wasting a little energy is always, always lower than the cost of missing a real predator. It was designed for a world where any weird sound could mean life or death. But to really understand that speed, we have to drill down into the heavy hitter.
The amygdala.
The amygdala.
The brain's undisputed center for fear. I mean, it's this deep, almond-shaped thing that processes danger. So how does it get switched on in this circuit without any actual concrete information?
This is where you see just how sensitive the system is. We usually think the amygdala fires up for obvious threats, a car horn, a shout. But in this scenario, it's switched on simply by the psychological feeling of having an eye on you.
Just the feeling itself is enough.
The pure, subjective sensation of being observed is a sufficient trigger.
But how does that bypass our rational thought? If I'm looking at an empty room, my prefrontal cortex, my logic center should be saying, everything is fine. Why does the amygdala win that fight?
Because the brain has two roads for sensory information, and the amygdala is on the superhighway. When you see, say, a flickering shadow, that information goes down two paths at once. One is the slow, detailed path up to your visual cortex for rational assessment. That's your logic.
And what's the other path?
The other is the fast, crude, sort of low-res path that zips straight to the amygdala. This path doesn't care about detail. It just cares about speed.
So if the input is ambiguous but potentially threatening.
The amygdala gets the memo first. And it starts the fight or flight response before your conscious mind is even finished figuring out what it just saw.
So the amygdala has already released the fear chemicals and started the whole physical cascade before the logical part of my brain even registers that the room is empty. That explains that cold prickle on the neck.
Absolutely. The prickle isn't incidental. It's the real physiological consequence of the amygdala kicking the sympathetic nervous system into gear. It's adrenaline, it's cortisol, prepping your body for defense. Right now.
And the system is so sensitive, you're saying it's triggered by incredibly small thing.
Minimal stimuli.
Like what? Give us some real-world examples. We're not talking about loud noises.
No, we're talking about subtlety, especially sounds your brain can't easily define.
Hmm.
A slight shift in air pressure, a distant dripping noise, the tiny sounds a building makes as it settles. If your brain can't immediately classify it as safe, the amygdala defaults to danger.
And visually, it's the same idea. That movement you see just at the edge of your vision, the one you can't quite catch.
Precisely, especially in low light, or if you're tired. A flicker of a reflection, a shadow moving on the wall, it's instantly flagged. Because that fast pathway to the amygdala prioritizes speed over accuracy every single time.
So that ambiguous shape is immediately labeled potential threat.
Potential predator, potential observer.
Yeah.
The amygdala starts pumping out the fear hormones just in case.
This biological map brings us to what I think is the most compelling part of this research, the evolutionary trade-off. We have this amazingly fast, super sensitive, but also wildly error-prone system. Why did evolution settle on this design? Why prioritize the error?
It takes us back to the survival math of our ancient ancestors. Let's say 100,000 years ago. An early human is alone, maybe in tall grass. They hear a faint rustle.
And it could be the wind, or it could be a saber-toothed cat.
The options are stark, aren't they? Ignore it and keep walking, or run for the nearest tree.
Okay, let's play it out. If they assume it's the wind, but it's actually the predator.
The consequence is lethal.
Oh,
Game
okay.
over. Their genes are out of the pool.
And if they assume it's a predator, but it's just the wind.
They waste a few calories. They feel a little foolish, maybe.
Mm.
But they live to hunt another day. Evolution doesn't care about feeling foolish. The core philosophy of the brain here is that it prefers a false alarm.
That's the ultimate takeaway right there. The brain prioritizes the false alarm, the wasted energy, the terror over the small possibility of ignoring a threat that turns out to be real.
It's an ancient, unchangeable risk assessment model. It sacrifices our comfort for our survival. The system has to be oversensitive. If the difference between life and death is one single guess, you need the widest possible safety margin.
And that's why we check behind the shower curtain even when we know we're home alone.
Exactly. It makes that fear feel less ridiculous when you frame it that way. The pounding heart, the tunnel vision, that's your brain acting as if your life depends on that response, because for our ancestors, it absolutely did.
You could be in a locked room, totally safe, but biologically, your amygdala just got a signal that it interprets the same way it would have millennia ago.
Ambiguous threat detected. Initiate maximum response protocol. The research confirms this intense reaction happens even when there's zero logical reason for the fear. The feeling comes before the facts.
And that persistence of ancient wiring is just so fascinating. The world has changed so much, but these fundamental pathways that kept us alive are still the dominant force in how we act in these situations.
Really shows how deeply ingrained these instincts are. When you feel that chilling certainty of being watched, you are literally experiencing a system designed to keep you from becoming dinner. It's not a bug, it's a feature. Perfect, ancient design, still running today.
Okay, so let's synthesize this. So what, for the listener, we've laid out the science. What's the most important takeaway from knowing all this?
I think the primary takeaway is validation. The sensation of being watched is not a sign of instability or irrationality. It's a real genetically encoded biological phenomena. Understanding that it comes from the hypervigilance circuit helps us, externalize that fear a bit.
And it reminds us just how much our evolutionary past still governs us. These primal fear responses are still hijacking our modern rational selves.
And knowing that is leverage. It lets us recognize that when that fear alarm goes off, it's often responding to ambiguity, a lack of data, not necessarily a clear and present danger.
So we can use our logical brain after the amygdala has already fired.
Exactly. You
Okay.
can acknowledge the feeling, hello, hypervigilance circuit, I see you're working hard, and then use your higher level thinking to confirm that there's actually no threat.
This deep dive really shows how strongly those old instincts persist, influencing us even when we're totally safe and alone. It's a remarkable testament to how robust those neural pathways are.
They are the pathways that ensured our survival generation after generation, and they're definitely not going anywhere.
So here's a final provocative thought to leave you with, building on everything we've explored today. If the human brain is hard engineered to prioritize the false alarm for protection, if the default setting is terror over safety, what does that mean for our modern lives? How many of our daily anxieties, that sort of background hum of stress and dread that so many of us feel, how much of that is just echoes of that ancient threat system firing on all cylinders?
Right. If the hypervigilance circuit is constantly being triggered by the ambiguities of modern life, endless notifications, complex social situations, financial uncertainty, what does that mean for how we manage our fear response, knowing our brain is running a stress test designed for the savannah?
The knowledge that the trigger is often just an information gap. That might be the first step in learning how to quiet the alarm. Thank you for sharing.